back. So I know electricity flows from positive to negative part, but I want to explain a bit more than that. So the wire would use is a conductor, most likely metal, most likely copper, and inside the cross section of copper wire, it's made of a bunch of copper atoms, which has an atomic number of 29. You'd see why that's important for a moment. In a copper atom, we do not care about the nucleus. I only care about the electrons. So we just look at the valence shell. The because it has 29 atoms, first shell has two electrons. The second is full, has 8. The third has 8. And that adds up to 28, I think. Yeah. So the last has the final one, which adds up to 29 atoms in total. So this atom, this 29 electrons in total. This electron in the outer valence shell usually just floats around in the cross section of a copper wire, like I would have here. Imagine different copper atoms. Copper, yeah. So this electron is actually it's called the negative charge. It gets to float around with these, and what happens is if this is connected to, let's say it's connected to some battery, the negative charges, the electrons are attracted to the positive, and the let's forget about this. Negative charges are attracted to the positive, and you notice electrons are actually moving this way and not the other way as we visualized here. So I explain it this way. Think of electrons as the actual charges, and then these don't really exist. These are more like spaces that these could exist in. So in that cross section of a wire where we have these charges, anywhere there's an empty space, think of it as a hole, which is just a potential. It's a space that an electron could exist in, a potential for an electron. Right? And what happens when we try to measure the difference in the potential of an electron? By the way, as electrons move in a direction, you could also translate that as the spaces moving in the opposite direction. This potential for an electron, what happens when we try to measure the difference between it across a wire? That's the potential difference, which I'm sure you've heard of this before. Is voltage. And that's why we think of it this way, even though in reality it's electrons going in the opposite way. It's actually, it might be easier for you to visualize this as spaces for electrons moving forward. And that's it for my first YouTube video. Thanks, Lean.